Arun Gupta. As Sasha said, and I was working with Sun, now with Oracle, for about 14 years. So I was part of the team that started the J2EE. That time it used to be called J2EE. The very first release that we did was in December of '99. So since then, the very first alpha release we released in March of '99, April of '99. Since then, I've been with the team in different roles and capacities. In past 6 years or so, I've been doing primarily technology advocacy. Means different things to different people. I'm primarily more on the side of technology. I'm no selling. I don't get any commission for selling my product, even though I have a product. I'm more about technology. So I learned the technology by holding it by the gut. I've authored a book on Java EE 6. I blog pretty excessively. This is my blog URL. And I'll share the slides on my blog as well. I got about 1,350 blogs over past 6.5 years. So tons of technical content on my blog. With that, so the way I'm going to structure the talk today, given that I have about an hour and a half or so, well, 1 hour, 25 minutes. So I'll cover a broader overview of the platform of Java EE 7 in the first 20-25 minutes. And the last 1 hour, I will keep it for the WebSocket API, which is a brand new API that is getting added to the platform. So we'll talk about what that API is going to offer. How many folks are familiar with WebSocket concepts? OK, yeah, that's about the number I expected. So what I'll do is first 25 minutes about Java EE 7 overview. And I'll quickly run through some of the slides. I'll not go through as I originally planned. So you'll see me skipping some slides. Then in the next hour or so, I'll split that between giving WebSocket primer and talking about the WebSocket API that is coming as part of JSR 356. How many of you don't know what a JSR is? OK, very few of you. Well, JSR is Java Specification Request. That's the way we create brand new standards in the Java land. And each JSR is given a unique number, JSR 356 being the API, the way we were defining WebSocket API in the Java EE platform. All right, let's get started. One thing that Oracle makes us do to put this legal slide in all our technical presentations, simply ignore it. Just ignore it. All it means is the dates here are only indicative. They're not definitive. You can't sue Oracle or me for saying the dates. Anyway, so Java EE 6, the platform itself, which is the latest version of the platform that is in production, was released over 3 years ago. Tons of features in there. But before we get into the features itself, there are tons of vendors that have Java EE 6 compliant application servers. You can see pretty much all the names that are in the Java EE land, they have a compliant application server. So open source offerings, commercial offerings, all sorts of plays are in there in the game. So you can build your application to Java EE and deploy them on a Java EE compliant server. There's plenty and plenty of choice that is available in the market today. Okay. In terms of the features, I won't dig deeper into it, but there are lots of improvements that were made in the Java EE 6 programming model. We actually did a Java EE 6 hands-on workshop in the San Francisco Java meetup, I think about a couple of years ago. Yeah, we did a hands-on workshop for 2 consecutive days. There were 3.5-hour-long sessions. It's about 7 hours of hands-on workshop. And we can come back again when Java EE 7 is released, which is Q2 of this year. We'll come back with the Java EE 7 hands-on workshop, giving you a lot more taste of what's coming in the platform. Lots of features in Java EE 6 in general. Simplified EJB deployment. Typically when you say EJB, people just push back. Oh, no, this is bulky, heavyweight. Single class, no deployment descriptor, packaging in WAR file. That's how we define EJB. Just a POJO, just an annotation on it. That's about it. That's what EJB gives you. Standards-based, type-safe dependency injection in the platform. That is CDI or JSR 299. That gives you full dependency injection, which is type-safe, not string-based, unlike other proprietary frameworks. Huge improvements in the Java Server Faces platform itself, which allows you to use faceless as the templating language. Let's see what else. Several other improvements in EJB. Again, I won't get into those, but this is sort of my top 10 list. What else? Web profile. We talk about Java EE being heavyweight. So we define something called as Java EE web profile, which is a lightweight version of Java EE. And so Glassfish, which is a reference implementation of Java EE, comes in two flavors. There's a web profile download, and there's a full platform download. The web profile download is 30 megabytes. In those 30 megabytes, you get a subset of the specification of the platform with which you can write a modern web application. So all the components like servlets, EJB, JPA, all those components, typical your database, middle tier, transactions, web services, all those components are part of that 30 megabyte download, tested and supported for you by all of these vendors. Now, with Java EE 7, the earlier path that we took was, we're going to provide a standards-based PaaS platform. But that means you would be able to write an application using Java EE 7 APIs, and then you can deploy it on any Java EE 7 compliant container that would run in the cloud. So kind of providing true cloud portability using Java EE. But then we realized, after talking to our customers, partners, vendors, that is too early. There's still a lot of standardization that needs to happen in the cloud world, essentially. More importantly, innovation that needs to happen in the cloud world. So we kind of pulled back from that based upon the feedback from the community. And we said, OK, the focus of Java EE 7 is going to be productivity and HTML5. And how are we going to give you those? Well, in terms of HTML5, we're providing a standard API to do WebSockets, JSON API, HTML5 data attributes. We're going to support those. In terms of productivity, JSRs like JMS have been going through major overhaul, allowing you to write very simplified code. And if time permitted, I may be able to show you a small sample of that. So it shows exactly how 18 lines of code just to send a message could be easily crunched to just a single line of code. Basically leveraging dependency injection and the language features that are already available in the platform.
Question real quick. When you say HTML5 support, are you also supporting CSS3?
There is no support that is really required to be done as, OK, the question is, when you say HTML5, are you supporting CSS3 as well? There is no additional that needs to be done from the platform for CSS3 support that comes as part of the browser itself. There is nothing that needs to be done in the platform per se. But when I go back here, when I say HTML5 forms, what it means is mapping those HTML5 forms natively to a JSF2 form and kind of defining a correlation between those two. Now, this is what we call as a pancake diagram for Java EE 7. There are different ways you can interpret it, but the basic idea is there are tons of specifications in the Java EE 7 platform. And the color legend you can see at the bottom, for example, JMS, JaxRS, and expression languages. Those three are going through major updates as part of the platform. And if maybe I can show some quick updates on that as well. Several other specifications are going through minor update. And the one on the far right are the brand new additions to the platform itself. So think about building a standard-based WebSocket-driven application. And I'll show you why it is important to build a standards-based application. Think about, instead of relying upon org.json or a third-party JSON library, that being available as part of the platform itself, wherein you don't need to bundle a third-party JSON library, where portability is guaranteed across your different application servers. Similarly, Java caching API that will give you a simple key value pair for scaling your applications very easily. We also have batch applications that is coming as part of the Java EE 7. So the point being, there are lots of existing content that is being revamped for productivity and HTML5. And same thing, same philosophy with the new set of specifications that are coming in. Well, today we're going to click on Java API for WebSocket, which is JSR 356. So we'll double click on that and provide a lot more details on that. Now, in terms of JaxRS 2.0, which is sort of the big update that is coming as part of Java EE 7 platform, tons of new features that are getting added. Now, if you realize, how many folks are using JaxRS today? OK, some of you. Well, JaxRS is a standard way to build a RESTful web service. And effectively, in JaxRS first version, what you could do is take a POJO, put an annotation on it, and say, I want to publish this POJO as a REST endpoint. Everything else was done by the JaxRS runtime. So then you could say, oh, what are my marshalling, unmarshalling concepts? What are my different sub-resources? or what are my HTTP get, put, post, delete methods, how do they map to my resource methods. All of that was defined by JaxRS in a standard way. Now, if you realize, it was all server-centric. So one of the new features that we're adding as part of JaxRS 2 is to do client-side API. What that means is, using similar concepts, you can invoke a REST endpoint using a client API, again, giving you portable applications effectively. Let's see a quick sample of that. So today, if you want to invoke a REST endpoint, let's say you want to use, your only option is either you use a proprietary API or you use the one that is bundled as part of JDK. So you have to really create your new URL, HTTP URL connection, set the metadata, and go through this nasty loop. It's kind of hard to understand, but you have to go through that loop. With JaxRS 2.0, you can just do a clean API. All you say is, I want to create a new client. With the client, I want to set the target. This is the URI that I want to invoke. I want to resolve the template, that this is my variable part of the URI. I want to set up a query parameter, which is question mark name equals value. I'm going to set those. I'm going to build the request. I'm going to do HTTP get. And I know that I'm going to get a string response back. So very clean, very simple API. I'm not digging into it, but that's one of the areas where we could talk a lot more extensively on how we can use it. So for example, here, instead of get, you can say put, post, delete, and all of those different verbs are available. You could start getting fancy, where you could say, you could define what type of data payload is going over the wire. You could even start putting your HTTP accept header. Oh, I expect application/JSON MIME type coming back as part of the response. So you can start getting fancy with all those things. Filters and entity interceptors, a new concept that we're adding as part of JaxRS itself that allows you to have request processing hooks or extensions, effectively, which you can do for request and response. Typical way is you want to do logging or any cross-cutting concerns, or you want to do auditing or security for a JaxRS request. Now, there are several implementations of JaxRS which were actually having those features in there already. This is, again, a standard way, again, promising the portability promise to you. So the idea is you could write a standard filter, which is primarily looking at the HTTP headers, or you could say, I want to start looking at the body and maybe start modifying the body itself. So for example, if you know that the request coming from the client side is gzip encoded, you can dynamically plug in a gzip interceptor, for example, which would know exactly how to read the request. Or if you know the client can understand a gzip encoded content, then you can dynamically put it on the server side gzip response handler, which would allow you to gzip your response dynamically. So your business logic doesn't change, but your cross-cutting concern just simply sit right there as an interceptor. And this is completely dynamic, by the way. So the question is, I'm using this in Jersey already today. What about backwards compatibility? Jersey is the reference implementation of JaxRS. So now JaxRS, of course, a lot of feedback came from Jersey per se, that how these features need to be built into the platform. But the features that you're using for Jersey, they continue to be RI specific. They may be supported, some of them may be supported in Jersey 2.0, but the definite guidance is to move towards standard API. One of the features, little nifty features that we're adding as part of JaxRS is how you can do server-side content negotiation. Well, today in the content negotiation, what that means is the client is saying, oh, you know what? I'm sending a request. I want a response back. Now, what kind of response do I want back? I'm a browser, so I want HTML response back. Or I'm an application, so I want JSON response back. So you can actually define that by using HTTP accept header. Now, if the request goes to a server and server don't care, what is the response goes back, it could send anything. Now, with this, what you're doing is, for example, here you're defining if the client does not say what response should come back, the server is defining a priority. He's saying application/JSON. By default, the priority is 1. So you're saying, by default, I'm going to send JSON payload. And if the client says text XML explicitly, I'm going to honor that as well. But by default, that's a lower priority. So small, nifty features, but hopefully we'll have a bigger detailed talk on JaxRS by itself. Now JMS. JMS was revamped or last revised in December of 2003. Long back. So, well, we're 2013, so almost 10 years ago, effectively. By that time, JDK 1.4 was not released. So there are a lot of changes that have been made in the Java platform itself. And the goal of JMS 2 is really to catch up with all those features or the improvements that have been made in the Java platform and incorporate those features as part of JMS 2.0 API. So if I were to quickly run you through this code, now this is all the boilerplate code that you need to write as part of just sending a simple message. And what are the problems with this code? If you take a look at it, there is lots of boilerplate code over here. Your goal is to send a text message to a message producer. But all of this boilerplate code needs to be written. There are tons of APIs that needs to be honored because that's how JMS is defined. You have to do the exception handling. You have to close the resources. You have to inject the resources. You have to create these resources. So there's tons of stuff that is happening just to send a simple message. Now see how that changes as part of Java EE 7. This is the updated code as part of Java EE 7. I mean, I didn't walk through all those slides. But the idea is we're just using CDI, first of all. We are saying just inject a JMS context. JMS context will have the encapsulation of the existing APIs that are available, like producer and consumer. Then I'm going to say, OK, inject my queue here. And this, of course, this is your specific queue, so you're going to define this by yourself. And then in terms of send message, all you're saying is from the JMS context that is injected for you, create the producer, send to this demo queue, and the payload. No boilerplate, very clean API. So effectively, there is no exception handling that's happening here. There is no resource handling that needs to happen. That is because JDK 7 defines how if a resource goes out of scope, it is automatically collected. So functionality like that have been used or incorporated into the API to make it much simpler and easier to use. Now, that doesn't mean that the older API is going away. Because it has been into existence and usage for such a long time, this is a new API that we are defining. So that means your JMS 1.1 programs will continue to work as is. But the idea, again, is to kind of start migrating towards JMS 2.0. Yes, sir?
What's the performance impact of this? Like every time it creates a new producer and creates a new session every time?
So here, what you're doing effectively is you're just creating a JMS context. In the terms of JMS context, you're creating a producer. Now, in the JMS context, what I'm not specifying here is what is my queue or what is my JMS connection factory that I'm using effectively. Now, depending upon how you have configured your JMS connection factory, it might be creating new producers or new consumers every time. Sorry, the question was, what is the performance impact of this code over the previous code? But there are dials and knobs that are available by which you can control that. Now, Java API for JSON processing, that's the brand new API that we're adding as part of the Java EE 7 platform. This API will allow you to parse or generate a JSON object using standard API. And just like JaxP, or Java API for XML processing, and JaxB, or Java API for XML binding, there is a DOM model and there is a data binding model that is available here effectively. So, actually, in JaxP, for example, there is a streaming API and a DOM API. So in the first version, what we're defining is a streaming API and a DOM API for JSON. Subsequently, we will have a JSON binding API, where on a Java object, you could specify annotation, and it will assume defaults and automatically bind that POJO to JSON or vice versa. But for now, it's only streaming and DOM API. In terms of streaming API, so think about this is how your JSON fragment looks like. You could, if you're familiar with JaxP, how streaming really works, so all you could do here is, I want to listen to the event. So the first event is fired is start object, or key name, or key value string, or value number, so on and so forth. You could actually act upon those events as they're being fired and do the relevant thing. A short code that basically says, this is my entire fragment. I get from the parser, I get an iterator. I just do next, next, next. And then eventually, these are the events that are being fired on each particular event. Bean validation. This was a new specification that was added as part of the Java EE6 platform. Now, the beauty of bean validation is it allows you to specify validation constraints on your beans. So think about a POJO, which is what you're using, or a JPA entity, for example, which is what you're using to persist to the database. Now, or think about a backing bean for a JSF page, where you're capturing results from a web page. Now, you could do the validation in the JavaScript. You could do the validation when you're capturing the data or before you're persisting the data to the database. The beauty of bean validation is on the bean itself, you can define the validation constraint. And the way the integration is defined across the platform is a bean validator would automatically kick in and would try to validate whatever constraints you have defined. For example, let's say you have a JPA entity. In the entity, you said, I don't want the name to be more than 30 characters. Now, when you're trying to persist the JPA entity to the database, it'll say, oh, let me make sure the validation constraints specified on the bean are actually being honored. If not, the validator will kick in, and it will throw a validation constraint exception. Now, either you do that in your application, or you rely upon the Java EE6 runtime to do the validation for you. If you don't do it, it goes to the database, and it throws an error back as well. So the idea is the cost. If you don't do it in your application, or the bean validation doesn't do it for you, it anyway goes to the database, and the error comes back to you. So, but this certainly makes it much easy. Something that they're doing as part of bean validation 1.1 that is coming in the Java EE7 platform is how you can start putting those constraints on your simple methods. So for example, let's say you're invoking you have a POJO in which you have a place order method. In the place order method, you want to make sure that if the product name that is being passed is to be not null. Instead of saying @not null, in your application code, which is in the place order method, you could start checking, oh, if product name equals null, then throw some exception or things like that. Or you could say, if the integer quantity is not 10, then throw an error back. Here, it improves the semantic readability of your code. Just by putting those annotations, effectively what you're saying is, oh, I don't want this to be null. I don't want this to be, I want this to be a not null, but the maximum value should be 10. The one at the bottom, for example, says, if I'm returning a date from the existing function, I want it to be in future based upon the current JVM timestamp. So it's getting fancier and fancier, effectively improving the semantic readability, as I said earlier, of your code, and allowing you to focus on your core competency, which is writing the business logic itself.
Is this an extension of JSR 303? Or?
This is JSR 303. This is JSR 303. So bean validation 1.0 was is it an extension of JSR 303? So JSR 303 was bean validation. This is bean validation 1.1, the next version of it. Exactly. Now, one of the points that I want to highlight here is these constraints, for example, not null, max, those are built in. But you can define your custom constraint here. For example, here I'm using @customer. I want this customer to be of a specific type, and I have my own constraints around it. So instead of putting @not null, @max, @this, @that, I can put all the constraints together in my simple class. Again, it's a separation of concerns. I put all my constraints in a separate class, and I put that class as a constraint here on the customer itself. Much simpler. New functionality that is getting added to the Java EE7 platform is how you can write a simple batch application. I won't dig into the details here, but just to kind of give you an overall concept. There is a job repository, which is where all the jobs are stored, which is where all the metadata is stored. A job operator can look at the job repository, trigger the job. A job effectively consists of 1 is to star, so multiple steps. Now, a step, as they have defined, has two different mechanisms. It could be either a batchlet, which is sort of a one-time job that you want to fire, like upload a file or do something, or more typical, a more typical and recommended design pattern is chunked processing, which is where you're doing reader, processor, and writer. So let's talk more about that a little bit. So this is the chunked and the batchlet processing, but a more typical design pattern is chunked step. So what that means is, effectively, you are reading an item and processing an item. You're reading an item, processing an item. And you're probably doing that n number of times. And after you have done that n number of times, then you're saying, oh, now I'm going to write the items. Write the items literally does not mean writing the items. It could be, for example, here, I'm going to calculate the balance of the account, and I'm done. Read the account, calculate the balance. Read the account, calculate the balance. And I'm going to do that for 10 of those accounts together. And then I define what my chunk step is. And once I've defined my chunk step, after those 10 accounts have been read and processed, now I'm going to shoot an email to all those, hey, here, your account statement is ready, for example. These batch steps could be scheduled, could be ad hoc, and all kind of things. And we're trying to figure out, well, we're working on exactly how this batch API could work very well, for example, with EJB schedules. You have an EJB cron-based job. How would you trigger it automatically from that? So that integration is still being defined. The central point where and how the job is being fired is really defined using job XML. So if you guys have used Spring Batch, this concept is actually taken from there, for example. So here what we're saying is, oh, I have a job. This is the ID. My job has 2 steps here. This step, the ID is init. It's a chunk type. This is my reader, writer, processor. I can define the sequencing. If fail happens, do this. And then this is my batchlet, which is saying, OK, process an email, one-time job. So the job XML itself is pretty comprehensive. But the concept is actually being borrowed from Spring Batch. If I were to correlate the job XML with the actual POJOs, which is how my application is being structured, so I have in my chunk, for example, an account reader, an account processor, and an email writer. I would define a POJO, which would say, oh, this is my, well, I have the annotation read item here. But I will define a POJO which will say item reader on the class. In the class, the moment I say item reader, it has to implement certain methods. And then one of the methods is called as read item, which is saying, OK, I'm going to read an account. This is where possibly you're using JPA, talking to the database, and getting an account back. So you see this is an account that is coming back to you here. Now, then you are saying, OK, what is my account processor? Then you're saying you're defining a POJO, which is account processor, in which you have add process item annotation on a particular method, which is where you're probably calculating the balance. And finally, you have write items, which is where you are passing the list of account. Well, you're not passing, it's automatically getting passed by the concept that you've defined a chunk over here. And this is you're using Java Mail to send email. So purely within using Java EE standard concepts, you can do all of these batch processing concepts very easily. Yeah, the question is that are the jobs stored somewhere? So the job repository is where all the jobs and the metadata of the jobs are stored. Now, if the container crashes, are the jobs resumed after that? That is still a TBD. Yeah. Now, as I said, only job XML is borrowed from Spring Batch. That's not the best batch implementation, though. Job XML, yes. Now, Java temporary cache. Question.
Can you have multiple of those annotated methods?
You can have multiple POJOs, but a chunk would define only one reader, writer, and processor. So you cannot have multiple of those. You can have multiple of those methods, but then they would be corresponding to multiple chunks effectively. So for example, in my war file, what I could do is in metainf, I could have multiple batch.xml, job1.xml, job2.xml, job3.xml. Each of those jobs could be end of the day job or end of the month job, things like that, or midnight job. And then those jobs are automatically scheduled, maybe say using EJB's at schedule annotation. In the job, so you will have a job operator.start method over there, which is referring to that job.xml. In that job XML, you have multiple reader, writers, and processors, which are corresponding to multiple POJOs, which have multiple methods. So that's sort of the structure of how the batch war file would be defined. Question?
Is there a Java API for it too, or do we have to use XML?
No, there is a Java API. Is there a Java API for batch applications? Yes. I prefer the annotation route, much simpler, but you can go the interface route as well. So you could say extends or implements, and all that concepts are available.
No, I mean instead of gluing those things together in XML, can you glue
No, instead of gluing them together in XML, can we glue them together using Java? No, there is no Java API. As I understand, the first version of batch only has the job XML as sort of the primary entry point. Would that be useful?
I think it's disappointing, but.
Well, and I raised that point as well to the spec lead as well. I think about a couple of weeks ago. And the reason I got back was because if you take a look at the job XML specification, it's pretty complex. You can do parallel jobs, serialized jobs. You can define dependency on the jobs. So it's a pretty complex DSL by itself. Capturing all of that in the Java language would not be easy. As a matter of fact, we've already kind of parked that issue. We're not going to deal with that in batch 1.0, but probably in a future version. This is a standard concurrence, standard caching API that we are defining as part of Java EE 7. Won't dig more into it. But we have this concept of a cache manager, which has multiple caches. Caches has multiple entries. It's effectively a key value pair. So we're defining how that semantics is going to work. And again, there is an annotation-driven approach over here or an interface-driven approach. Both the approaches are available here. If I were to show you a simple sample, so for example, what you would do is you would obtain a simple cache manager. So you say cache manager.get. Well, first of all, you get a cache manager by using services mechanism or automatically identified. From the cache manager, you get a cache. So what is my test cache, for example? And then you can start playing around with it. You can start configuring the cache, how the cache is going to look like, what the values are going to go in. This is how you put a value in the cache. So you're just doing a simple get me the cache, give me the integer, cache.put. Okay? This is how you can get a value from the cache or remove from the cache. And now let's take a look at the annotation-driven example. So let's say I have a POJO, which is where I have already implemented, for example, a blog manager. How would I JCache enable it, for example? Well, all you do is you start putting @cache put annotation where the entry is being created. You just define what the cache name is going to look like, and the JCache runtime will automatically kick in and create the cache for you. Every time you're creating a title with a blog, you just say, what is my key, what is my value? You start sprinkling your annotation, and those values are automatically stored for you in the cache.
So is it like what kind of cache?
It's a key value pair.
No, like I'm saying, is it a distributed or local? Or
There are both the distributed or local. They're both the versions that are available. As part of JSR 107, there are several implementations that are being planned. There are 6 or 7 implementations that are being planned. The local version is required as part of JSR 7. Distributed is optional. So we expect some implementations will offer both. Some will offer only local. Now similarly, the way we have create an entry, we could say get blog entry. Then you can say just add cache result. From this cache, this is my key. Just give me the value. Or I want to get cached entry only. So you could pass a random arg. Well, in this case, by default, since there's only one parameter, that is the key. In this case, if I'm saying a specific method, then I can pass a random arg, and I can even tag it what my key is. So those annotations and convenience are all there. Similarly, I can say remove blog entry and remove all blogs. There are corresponding annotations for that. So cache enabling an existing POJO is pretty straightforward. One of the new features that is being added to JPA 2.1 or Java Persistence API 2.1 is how you can take a JPA entity and generate schema from it. Now, if you realize, Java Persistence API works on a pluggable persistence provider mechanism. So Eclipse Link or Hibernate are persistence providers. Now, most of those persistence providers define a mechanism, or if your JPA entity says add entity, add column, this, we can generate a DDL or a DML from that. This is effectively standardizing that. So you could say, you know what, if my JPA or my entity is going to look like this, then I could specify certain properties in persistence.xml, and that would basically allow me to generate my DDL. And where is going to generate? Is it going to be just into the database, or I'm going to generate actual SQL script. All those options are available to you. One of the new features that we're adding as part of Servlet 3.1, which is again the update for Servlet 3.0, is how you can do non-blocking I/O. Very standard methodology in the sense that, well, today if you have to do I/O, or in a traditional way, what you would do is in a do-get method, you say, I'm getting a request from the input stream. I'm going to keep reading it until it says, OK, I'm done. So this is blocked. Effectively, you're blocked on reading the input until the stream is closed from the other side. So the workaround is, which is a very standard way, we're defining callback handlers here.
This is kind of doing something like Mina.
Say again?
Something like Mina.
Mina?
The way Mina does.
Apache Mina?
Yeah.
I don't know what Apache Mina. Well, I know what Apache Mina is, but I don't know what they do.
I mean, it has a callback kind of thing. Whenever you get a data, it just keeps calling that.
Possibly. Yeah. It's a very standard approach, though. Yeah. So here, for example, what I'm saying is, on the input stream, I'm just setting a read listener. What is my new read listener? And then my read listener actually has an on data available method. So whenever data is available, it just calls that read listener. It runs in a separate thread, and it says, OK, input is ready. I'm going to keep reading it till the data is available to me, and I just loop through it. So it's very standard, very stereotype concept. This is yet another API that is getting added new to the platform. I know it's JSR 236, so it's kind of old, been working with it for a long time, but finally getting included as part of the platform. One of the limitations, so to say, that people feel for the Java EE platform is they cannot create new threads. That's not required or permitted by the specification, although some of the containers do permit it. Now with this, you can actually have managed executor threads. The idea is you can ask the container to create threads for you, and the container will manage it for you. So that's sort of what this concurrency utilities for Java EE will provide you. The idea is, you can define in your JNDI resource references, oh, this is my managed executor service, what is my reference type, and this is where I want to have my batch executor. So you inject a batch executor effectively using JNDI reference. Then from that batch executor, you can say, start spinning up new threads for me. So here, for example, I'm saying, OK, inject my batch executor, which is my managed executor service. On the executor, I can say submit. By the way, here you can also define how many threads you want to be available in the pool. So all those parameters are configurable. One of the improvements that we're doing as part of the broader Java EE platform is how we are taking, for example, EJB has this core concept of each method is inherently transactional, for example, unless you explicitly call it that, OK, it's not transactional. Now, that concept is relevant to the broader platform as well. So what we're saying is, let's take that concept out of EJB and make it much more widely applicable. So for example, this is an add transactional annotation that could be applied to a POJO. Now, what that means is the semantics are defined by EJB, or the semantics are defined by JTA, which is Java Transaction API. We're revving that as part of the platform as well. JTA will define what add transactional will do, but you can actually put it on any POJO. And the way it works is because Java EE 7 has context and dependency injection, which, by the way, introduces your transactional interceptors over there, or at least interceptors, it's basically leveraging those concepts for making it seamless for you. The idea is it need not be an EJB if it has to be transactional. You can make your POJOs as inherently transactional by just putting this annotation. If you put it on a method, the method becomes transactional. You put it in a class, all the methods in that class become transactional. All right. Now, most of the APIs that I talked about, other than say concurrency utilities, batch, and JCache. Those are the three big ones that are not there as part of download today. But most of the APIs are already integrated and implemented as part of Glassfish 4. So you can download the latest promoted build here. Build 70 was done on January 3rd, which is what I'm running on my machine today. And I'm going to show you some sample code with WebSocket. And so all those APIs are integrated. You can try it. You can play with it. You can provide feedback on that. And I think that's a good segue for something I want to talk about. How many of you are familiar with the AdapterJSR effort? 1, 2, 3, 4. OK, excellent. Good audience then, and I can explain it. Well, AdapterJSR was an effort that was originally started by London Java Group. They started looking at different JSRs in terms of, oh, let's take a look at JMS 2.0. And as a jug, we're going to meet together and have a hack day. And we're going to download the specification. We're going to read the Java docs, see if it makes sense, see if there are any typos. We're going to build an application using JMS 2.0, things like that. Now, what they did is they sort of formalized the program where other jugs could actually take that same concept. And they say, oh, we're going to adopt a JSR. Not just a JSR, you could adopt a bunch of JSRs. So now what happens is Java E7 is the one, Java E7 JSRs are the ones that are most active today. So as part of that, we formally launched a Java E7 AdapterJSR program. So for example, somebody in San Francisco Java user group, or in this meetup, for example, could say, oh, you know what? I really care about JSON API being done right. So I'm going to build an application, or I have a use case. I'm going to use that API to implement my use case and see if that API fulfills my need. Or I'm going to talk about WebSocket API now, and you feel excited about the WebSocket API. So I'm going to adopt that JSR as part of the WebSocket of the San Francisco Java meetup, and I'm going to start playing with the API. What that could mean is you can download the spec, look at the Java doc, build an application. You could even start contributing to the implementation. Or you can even provide a proposal to the specification. Oh, I know how WebSocket and Servlet and EJB should work with each other. And I think this is critical enough that it should be specified in the specification. So there are whole tons of activities that you can do as part of AdapterJSR effort. It could be as simple as just understanding the specification, talking about it with your friends and your company, giving a presentation at the meetup, could be writing a proposal to the specification, could be implementing it, talking at a conference. Any sort of activity can be done as part of AdapterJSR effort. So how do you get started? That's the typical question people ask me. OK, fine. I'm sold. I want to get started. So what we did is, on glassfish.org/AdapterJSR, we worked with different specification leads. And we said, OK, what are the areas where you're looking feedback for? So on this URL, I have this list of specifications. So the ones that are in black, they don't have a specific list. So there we have general areas of feedback that are recommended. But otherwise, for most of the APIs, you have specific areas where the specification leads are looking for feedback. Now you may wonder, who is doing AdapterJSR? So today, there are 15 Java user groups around the world that are actually doing AdapterJSR. So for example, this is Hyderabad Java user group. What they're doing is they are building an application using different Java E7 component. And literally, there was this one girl in Hyderabad. I met her at Java 1. She reached out to me, Arun, I care about JPA, and I want to adopt a JSR. The jug leaders are not responding. So I went from the other side. I know the jug leaders. I kind of coaxed them in. I connected the dots. And now they're working together to build an application using Java E7. They're actually organizing hack days, for example. BE Jug, which is Belgium Jug. These are the guys who organize DevOps, for example. They have adopted JSR 356, the WebSocket API. So what they're doing is they have actually given contributions to the RI already. They're actively participating in the RI list. Not only that, but they're already planning to organize Hack Day. So they're going to build a tic-tac-toe kind of an application using WebSocket. So Java, they're actively contributing, for example, to Java Server Faces 2.2. They have contributed a JSF application already in earlier days before AdapterJSR. And they're continuing to enhance those, incorporate JSF 2.2 features. London Java community. These guys are very big on JMS. They've already organized JMS hack days. I believe it's Cologne Jug that have started contributing to JSON performance issues. So there's a tons of activity that you could do here. It would be great if one of you could take a leadership, and I'm local here, so I'm happy to kind of do a hangout with you, or come back again, kind of organize a hack day. Oh, let me give you a quick overview of all the Java E7 technologies, help you define the application, and then you run by yourself. I'm here to help it facilitate. The key point being, Java E7 is scheduled to go final in Q2 2013. So all this work needs to happen pretty much now. So somebody needs to kind of, while driving back to your home, the bulb needs to light up and say, hey, I'm going to do it. Send me an email or send Sasha an email, and I'm happy to kind of coordinate that effort with you guys. Let's switch the slides. Let's talk about HTTP. HTTP has served us really well so far. The purpose of it is served really well, and all the web is resting on it. But effectively, it's half duplex in the sense, you send a request, a client can send a request, and then once the request is received, that's when the response comes back. It's chatty, it's very verbose. Just to send a simple hello world, you have to send like about 2 kilobytes of data is exchanged between client and server. Just look at the amount of HTTP headers, bare minimal, that is required. So it's very chatty. So it's not really effective for real-time communication that you want to do on the web, at least. So it doesn't scale for that. So people started hacking around HTTP, server push, Comet, different technologies that are coming along as part of it. But again, those stay to be hacked. So there's no standard mechanism up until now. So that's exactly where WebSocket come to the rescue. Now, originally, WebSocket was proposed as part of HTML5 standard, but HTML5 itself is not going to be a standard until 2014, until next year. So what they did is they pulled WebSocket out of it, and they said, OK, it's going to be an IETF document, which is a fairly well-known body, and it's a standard, basically. HTTP is an IETF document, effectively. So there are two things that are defined as part of WebSocket. First is the wire protocol, as in how the wire protocol is going to look like. There's still a concept of a client and a server. So when the client and the server are talking, how does the handshake happen? How does the on-the-wire message look like? How do we get away of the chattiness of HTTP and things like that? And then the second part to WebSocket is the JavaScript API. We're talking about web, JavaScript being the lingua franca of the web. We're defining how a JavaScript API is going to look like. So JavaScript API is defined by W3C. It's in candidate recommendation, which is a fairly advanced stage. The next one is pretty much recommendation. And IETF is already a defined protocol. So just Google for RFC 6445, and that tells you exactly. It's a fairly well-written document. It's not one of those geeky ones, so you can easily read it and still understand it. So what's the basic idea? Now, well, let's flip the slide. I think there's too much details in there. But the basic idea really is, you have a client and a server. Okay? Now, client and a server, they are talking HTTP. On HTTP, HTTP defines an upgrade mechanism, which is defined as part of the HTTP specification itself. That upgrade mechanism was defined. Say you want to upgrade from one version of HTTP to a newer version of HTTP, or from HTTP to secure HTTP, and things like that. So if you're doing HTTP communication already, WebSocket defines how you can use that upgrade mechanism to upgrade from HTTP to WebSocket. And that is called as Handshake. So there's a client and a server. Client sends a handshake request. The server understands the request and says, OK, I'm talking WebSocket, handshake response. Or if it's not talking, then there's no handshake response. Effectively, you break the communication right there. How does the handshake request look like? So let's look at these headers. Now, these are the bunch of HTTP headers that go as part of the handshake request. You're saying, I want to do a GET, which is a standard HTTP, which is going to this URL using HTTP version 1.1. You got a host. These two are the critical headers that go as part of the request. So you say, I'm requesting an upgrade to WebSocket, and it's connection type upgrade. And then there are a whole bunch of metadata that goes along with it, origin, security, etc. Not really relevant. Now, if that request goes to an endpoint that understands or knows how to talk back to WebSocket, it responds back like this. Oh, yeah, I got that request. I know you're trying to do a connection upgrade to WebSocket. So I'm switching protocols now. I'm switching from HTTP to WebSocket. This is the very important line that you must see in the protocol response coming back. And then it responds back with the metadata as well. So that's sort of the handshake request response. Now remember, this runs on top of existing HTTP. So you make the initial connection using HTTP. You send a request, and the connection gets upgraded to WebSocket. None of the HTTP semantics are valid after that on that connection. So once the handshake request and response, let me go through this flow, then we'll take questions. Now, once the handshake request and response is done, that means my client and server are connected. Now, the important part to realize is the client is only client from the perspective that it is initiating the connection. And server is only server from the perspective it is receiving the connection. Once the two are connected, they're both peers. They're both equally capable of sending as many messages as many times and terminating the connection. That's why it's full duplex. Client and server can send any messages anytime, can initiate the termination any point of time. We'll get to that. What is the role of browsers to it? So we'll get to that. So now, once the connection is established, now imagine, even though I'm using the words client and server, they're effectively peers. So once the peers are established, there is a callback handlers that are on both the sides, client and server, open. So you can do some processing over there. Now, client can start sending messages, 1, 2, 3, as many as it wants. Server can send as many messages. There is no predefined that, OK, client has sent a request, the response has to come back. Client can send as many requests as these are unidirectional requests, unidirectional messages, so to say. The client can send, or this peer, the peer on the left side, say, can send as many requests, and similarly, the peer on the right side can send as many requests. There may be an error. I don't like the data format for some reason. And finally, one of them, either client or server, could initiate the termination, in which case the connection is terminated, and all that state is lost. So that's sort of the flow, basically, you would see. Now remember, the number of messages on the client need not equate the number of responses on the server. So effectively, you get a very, very low-level protocol here, where client can send as many messages, server can send as many messages to each other. You build your message exchange patterns on top of that. Now, whether it's request response, whether it's 1 request, 5 response, you define that. And there are well-defined mechanisms on how you can do that within the WebSocket. That's the concept of sub-protocols. We'll not cover that today, but that's how you can define it. And there are connection negotiation mechanisms that are defined on how those sub-protocols kick in. Now, you were asking the question about what is the role of browsers in here? Well, the browsers, we said JavaScript is the lingua franca. Now, effectively, if you're writing a web application that is talking to a WebSocket endpoint, so you're using JavaScript API. Now, this is the JavaScript API, which is a candidate recommendation that is defined by W3C. And if you take a look at it, it says this is a WebSocket API. This is a URL where you are connecting to. There are some steady state, ready state variables. These are my callback handlers. So for example, if the WebSocket connection is open, then call this. If there's an error, call this. These are my extensions. This is my protocol. Here I can actually pass my sub-protocols that I care about, which we talked about briefly. And these are the methods by which I send a request from one peer to the other peer. And I can send, for example, string data, or I could send binary data. Now, JavaScript has native binary arrays, and you can use all of that. By browser compatibility, what we really mean is, does the browser, well, you can't take this JavaScript API, bundle it as part of application. So by browser compatibility, what we mean is this API supported natively in the browser? That's the key part. It's a very detail-oriented protocol in the sense it exactly defines how your data frame needs to look like. Well, if you send a WebSocket message, it goes as a frame. Now it defines exactly how the framing should look like. And you can see, by detail, I really mean is it really get down to 0th bit, first bit, second bit. These are bits. So really, in terms of chattiness, where we're talking about 2 kilobytes of messages being exchanged, or 2 kilobytes worth of data being exchanged between client and server, here we are really talking about a 2 byte of overhead for each message exchange. That is basically the framing byte. Everything after that is data. Now, of course, the connection negotiation, of course, is a little bit chatty because that's relying upon HTTP. But after that, it works pretty clean, much less verbose. Talking a little bit more about browsers. So you can go to this website called as caniuse.com/websockets. Let me ask a trick question. How many of you use IE, Internet Explorer, as your primary browser?
What is that?
One hand. And the reason I ask that is this chart was updated in literally December 23rd of last year. Up until then, IE did not have the WebSocket support. Now they finally have. So if, for example, IE 9 is your primary browser, do not expect WebSocket from it. It will just not work. As a matter of fact, Firefox, Chrome, Safari, Opera, they have had this support for a while. Of course, Firefox and Chrome have had it for the longest time, effectively. Now, one thing that I fail to understand is why Android browser doesn't have that support. I don't know. But if you download Chrome on your Android phone, then it has that support. Just the native Android browser doesn't have it.
Isn't there a download for IE too as well? Chrome download for IE?
IE download for what?
There is something that will allow you to view what is viewable in Chrome. You can view it on IE.
I don't use IE, so I don't know what's happening in the IE land. I'm on a Mac, so I'm thankfully away from that virus. Now, we saw there is a JavaScript API for building the WebSocket applications. What happens on the server side? So on the server side, there are a whole bunch of frameworks that are available by which you can build a WebSocket application. And these are some of them. These are only some of them. And that's exactly the problem that the Java API for WebSocket is trying to solve. So JSR 356 is going to define a standard API for building WebSocket application. Now, as part of W3C, we have defined how the JavaScript API is going to look like. 356 or JSR 356 will also define how a Java API for that would look like. So it's defining not only the server programming model, but the client programming model as well. Tyros is the reference implementation name. It is already integrated well into Glassfish 4. And I'll show you some demos on how the code would look like for that. Skip through that. Yeah, so there is API for client and endpoints. We'll cover these a little bit more. WebSocket has this concept of extensions, which is sort of defined in the protocol itself. Now, as I said, WebSocket is a very low-level protocol, and it's text and binary supported both. What if you want to do multiplexing on that? You want to kind of take it a notch above that. So multiplexing, that's a tip, or compression, for example, on your WebSocket protocol. That is being supported using extensions in WebSocket. So now the WebSocket protocol defines that, but that's still in a very early stage. There are some experimental work going on around that, but that's not going to be supported as part of the Java API. And that's the reason that was originally in the scope, but we kind of ruled it out. That is too aggressive to support that, specifically given the state of extensions in WebSocket protocol. Yeah.
The WebSocket negotiation issue. Is there any? I just saw it came from another event where QDOS attacks, DDoS attacks are an issue. This open channel, the WebSocket open channel between server and client. Is there any security issues that are more, vulnerable for DDoS attacks, or is that just pretty much vulnerability?
So what are the security issues around WebSocket, specifically with denial of service? Now, just like your standard HTTP, that can happen here as well. Now, and I'll talk more about that. Once you establish a connection, you can establish a connection using plain WS colon protocol. So instead of HTTP colon protocol, you make connection using WS protocol, WS colon protocol, or you can make it using WSS, which is secure. So you can get away with that.
So when you are secure, you are exchanging the keys every time the communication is done, like with the encryption.
That key handling and all that is not defined as part of the protocol. So that is done exactly the way HTTP is doing it. So it's exactly leveraging those exact concepts and extending them to WebSocket. Is there a way by which we can switch standard Java servlets to WebSocket model? No, that's not how we expect it to work. And hopefully, I'll jump into the code soon, and then you'll get a better understanding of how we expect it to work. Just a warning, that's my legal disclaimer, by the way. So this is how I define my WebSocket endpoint, for example. So just read the code that is in the black, for example. I'm saying public class hello bean, simple say hello method, take a parameter, hello name. That's it, right? I want to convert it to a WebSocket endpoint. So I say, OK, import JavaX WebSocket package and host the WebSocket endpoint. WebSocket is effectively an endpoint. Which is where my client is talking to. So it's saying host the WebSocket endpoint at /hello. So you just provide the annotation, put the path in there, the WebSocket or JSR 356 runtime kicks in, automatically hosts it for you. That means it understands the requests that are being made to this endpoint using WS colon protocol. All of those it will understand. All the semantics, protocols, etc., connection negotiation, it will understand all of that. You're saying whenever a request is coming to this endpoint, invoke this method. You're tagging it as a WebSocket message. Now there could be multiple methods that could be WebSocket message, and I'll talk about that. But this is your simplistic, most trivial hello world example for getting started with WebSocket message or WebSocket endpoint. There are lots of other annotations as part of JavaX WebSocket star package. We looked at the first one. If you want to make a client, then you can just put an annotation at WebSocket client annotation. Now, of course, there are packaging on how you do the packaging, how do you bootstrap, what URL it's listening to, and I can cover that if we have time. But that's sort of the basic idea here. You do a WebSocket endpoint on a POJO, it becomes a WebSocket endpoint. You make add WebSocket client, then you have mechanisms on how it can connect to server and then become peer to that network effectively. There are callback handlers like open, close, error. You can define path parameter just like JaxRS, that if, let's say a request is coming in as part of the URI, you can say this is a variable part of the URI, map it to this particular parameter of the method. All that is possible. Within the WebSocket endpoint, there are 4 attributes that are available today. Well, first, of course, is a value, which is defined the URI at which the endpoint is listening. Now, as I said, the WebSocket endpoint itself can receive text data or binary data. One of the lingua franca of the web is, for example, JSON format. So now, does that mean every time you receive a JSON object or a JSON fragment is received as string, then you use a third-party JSON API to process it, and then you kind of play around with it, and then finally convert it back to string and send it back? No. Well, that's how people do it. But what we expect is you would define an encoder and a decoder. And that in that encoder and decoder, again, going by the separation of concerns design pattern, in that encoder and decoder is where you will specify that, oh, string is coming in. I'm going to convert the string to my POJO. Oh, that's my decoder, right? Now going out, you could say, oh, I want to deal with my POJO, but effectively on the wire, what has to go out is JSON. So encoder will do from my POJO to JSON. So this is exactly what you specify in encoders and decoders. So try to get hold of the concepts, and I'm going to show you a much more comprehensive sample covering all these concepts in the code. Question?
So is there any integration with JMS? This is basically a messaging system. Is there a way to seamlessly have an implementation of JMS using WebSocket so that you can just handle it like you would any other messages in your backend system?
Is there any integration of JMS with WebSocket? Not at this point of time. And that's exactly the point for our next bullet, for example, sub-protocols. Now, as I said, WebSocket is a very low-level protocol. Any messages that goes on top of it, you define the semantics for it. So there are 4 predefined sub-protocols that have been submitted. I mean, there's a formal process on how you can define a sub-protocol. As part of the sub-protocol, you need to define, oh, what is the request-response message pattern, and how those responses need to be dealt, and how those requests need to be dealt, et cetera, et cetera. So one of the message exchange pattern is, for example, how you could do JMS-style messaging with that. So that may be something that you can take a look at. But I think that's a very bleeding edge area, very gray area. More than welcome to take a look at it. I've looked at the proposal by itself, but I don't know if there are any implementations. I think WAMP is WAMP is what you may want to look at. It talks about a little bit about how that protocol is implemented within them. So we were talking about how I can convert from JSON to my POJO and POJO to my JSON. You define those encoders and decoders, and you effectively put them right here in this annotation. How would the code look like? Well, I have a public class, my message. I'm defining decoder.text. I know that this is going to be a text message coming to me, and I want to encode it back to the text. So I'm going to implement decoder.text and encoder.text. And all I'm doing is in the decode, well, first of all, will decode. That means in terms of decoder, if the string is coming to me, string is the payload coming to me, and I can maybe read ahead in the string and return true. Oh, I can process this message. So I return true, otherwise I return false. Now, this is how the JAX or WebSocket runtime or JSR 356 runtime will decide whether the encoder can handle the message from one format to other. That's one. And then there is a decode method here, which says, oh, OK, I got the string now. I want to convert this to JSON object, and then that goes right here. So that's sort of the decoding part of it. Similarly, encoding. You can say, oh, take the my POJO object, which is my message in this case, convert it to string. So just simple methods. Similarly, you can do that same thing for binary as well. So you can start playing around with binary data, convert, encode, and decode from binary to your POJO. Right. So well, the question is, if you're writing this Java WebSocket code, is that part of the WAR file? Yes, it is part of the WAR file.
And so that WebSocket endpoint that you specified /hello, is that relative to the context of that specific?
That's right. Excellent question. Is the URI of the WebSocket endpoint relative to the context root of the application? Yes, it is. So again, I'm just going through the concepts quickly, then I'm going to jump into the application. There we can see a lot more details on how this is actually being implemented. Say again? Oh, I know my time, don't worry. You want me to stop now? This is how we would write a very simple chat sample, for example. I have a chat bean. I'm going to say, in the chat bean, I'm going to collect a set of session. Now, session encapsulates how a client is making a request to the endpoint. And that's the list of sessions, for example. I'm going to just maintain that list of sessions. So the way I would write a simple chat client, and this is a fully operational chat server, for example. Here I'm saying on open by tagging add WebSocket open annotation on it. I'm just adding to the set over here. On close, I'm removing from the set. And then whenever a message is being received, I just broadcast the message to everybody. Very simple chat server, fully operational. And it's not fancy, but it does the job very well. So let me show the sample now. So I have a simple whiteboard application. Okay, let me show the application first. Then I'll walk you through the code, the directory structure, and the calls, and the flow, etc. So right-click and run it. This is running on Glassfish build 70, which is the most recent one that was promoted January 3rd, I think. The idea is this is a collaborative whiteboard. Whatever you draw on one browser gets displayed on another browser. So this is what I'm using is Chrome. Let me open up a Safari window here. And I can use Firefox as well, by the way. So let me refresh this guy here. Okay. So I just refreshed the page. So let's focus on the left window first, okay? So I'm looking at the developer tools here. I can click on WebSockets here. So it's going to show me only the WebSocket connections that are happening as part of this network traffic. Now if I take a look at that, so it says, okay, I'm requesting the URL, which is on WS colon. Now remember, I said this is not HTTP colon. This is WS colon URL. So it's making a request to this URL. Whiteboard is the name of the application. WebSocket is my endpoint where it's being hosted, the question that we were asking earlier. So the headers, the response that I'm getting back is HTTP 101, switching protocols. And these are the request headers. So I'm saying connection upgrade. This is the origin host, version, etc. And then in the response, I'm saying connection upgraded of the type WebSocket. Okay. So that's that. So let's keep it minimal for now. So the way this application works is, let's say what happened here? Connection close frame. Okay. Let me restart my server because I think it was running already. And once I come here, I join a different network, so it gets confused by the IP servers, IP addresses. Let me run it once again. Now, in terms of how the application would behave is, okay, that's how it should work. So the idea is, thank you. So whatever I type, whatever I do, this is a collaborative whiteboard. The idea is, imagine you running the show, and whatever you're typing on your whiteboard, you want it to be reflected across the different browsers. Now in this case, I'm just running 2 separate browsers, but if you have access to this network, then you can actually access this machine on your iPhone or whatever it is, and then you would see the exact same replica, for example.
No, it is using a different protocol, WS, I would say.
Right.
So how is the effect on the routers or firewalls? Because they have.
Let's look at the application first, then we'll talk about that. Okay. Let's try to understand the basic WebSocket concepts here first. So now, if I show you the developer tools, for example, here once again, and refresh it here, refresh it here. Just look at the WebSockets. Show me the WebSocket only. Oh, what happened? What happened? Why did my server die? Operation timed out. Okay, let's try it again. Operation timed out. So let me show you the index.jsp page in the meanwhile. So in the index.jsp page, all I have is a HTML5 canvas. Then I have some radio buttons. You choose the color, you choose the shape, and then you could do transfer. In the transfer in the sense you could transfer as soon as I click on the browser. I don't know if it's up or not yet. Oh, there you go. I think is it coming live or not? Oh, it's still starting. Oh, I just started the server. I didn't run the application itself. Okay. Let me walk you through the application first, show the behavior effectively. So here, for example, whatever I click here, that gets shown over there. I could choose a different color. That gets instantly transferred. Now I say, you know what? I don't want to do instant transfer. I want to go offline. I want to do some of my own work. So then I say, don't do instant transfer. Select some other stuff here, other shapes, other color, play around with that. And then I say, now send a snapshot. So the use case here is, every time I'm clicking, effectively is capturing the JSON coordinates. Well, this is a predefined template, right? Both of them are accessing the exactly same web application. So every time I'm clicking on this browser, is capturing the JSON coordinates, broadcasting it in just my chat server, broadcasting it to all of my clients that are listening to it. And that's how they're getting reflected over here. The moment I say don't send instant transfer, that transfer is not happening. And when I say snapshot, effectively is taking a snapshot of this HTML5 canvas and is sending a binary snapshot, not text this time. It's taking a binary transfer and sending it to all the other browsers. So for example, let's say if a third browser now joins in. I don't know what the timing out problem, but let's try this. So let's say I start a third browser. I go here. And here I say, for example, snapshot again. So the same thing is sent instantly again. Now it's a very simple sample, but the concept it conveys is you can do a multitude of things with this application. Let's take a look at the code with this. So this is my instant box. So as soon as I say instant, it's sending the JSON coordinates back to all the clients. And if I'm saying instant is false, that means I'm sending a binary data here. Okay? And see how that's being done. So if I take a look at my WebSocket.js here, in WebSocket.js is where I'm actually making a connection to the backend. Instead of using HTTP : I'm saying WS : location host, location path name, and WebSocket, which is where my endpoint is hosted. So if I take a look at my endpoint for a second, so this is where my WebSocket endpoint is hosted. Okay? And in this, all I have is WebSocket open, close, and I'm saying broadcast figure. This is using figure. Now figure is my POJO, which is where I'm sending my JSON coordinates. And then here I have byte buffer. Remember I said you could have multiple WebSocket messages. The first one is what takes the text version of the JSON coordinates. The second one is what is taking the binary snapshot and broadcasting it to all the different servers or all the different peers.
So it is bound to the mind frame, or how?
Say again?
How does it know which one to call, the broadcast snapshot or the?
If you take a look at figure, for example, up here, that figure is supported using these encoders, which are defined in my WebSocket annotation itself. Now, if I take a look at figure encoder, it says it's implementing encoder text figure. So that's sort of the algorithm it says. Oh, let me take a look at all the encoders, decoders you have specified as part of the WebSocket annotation. If any encoder serves that, then I'm going to take string, map it to that particular encoder, convert it to the POJO, and dispatch to the appropriate WebSocket message method. Now these are my simple coordinates. This is just there's nothing fancy here. If I take a look at my figure object itself, in figure, effectively, all I'm doing is storing the JSON coordinates. Okay. And if I were to show you, for example, my whiteboard.js, which is where my application logic is in there. Again, there I'm just using standard HTML or JavaScript syntax. I'm just using, get me the element by ID, get me the context, which are standard HTML5 APIs. I'm defining the image, based upon my radio buttons that are being selected. And this is my defined image binary. Again, I'm using the HTML5 APIs here, or JavaScript APIs. From the context, I'm getting the image data, creating my array buffer, and sending it over. Okay, this is my draw image text, which is where I'm directly transmitting all the JSON coordinates of the image, for example. You can see it required me a lot of experimenting to get this code working. But this code is all available. I mean, a full blog which shows exactly how this application should work in terms of Glassfish build, source code, all is available, already published on my blog. Now, if I go to, for example, files here, whiteboard, target, take a look at my whiteboard.war file. Now, this is generated with Maven. So of course, it has some additional classes. But if I take a look at my WebInf classes, effectively, those are all my classes in there. So there is no servlet, no EJB, nothing of that sort in there, just my WebSocket endpoint classes. And in terms of WebInf lib, Jettison and Stacks API are bundled in there, but I could actually move them into the provided category, and they won't be required as well. This particular version, again, I think I should be able to move it to the provided category, and that should work too. Question?
The collaborative whiteboard, does that work cross-platform? Doesn't matter what device, as long as it's WebSocket.
I tried it with my iPad, my iPhones, and across Windows. Well, not Chrome on Windows, and Mac, and some other machines, and it did work. Yeah, the main requirement being the compatibility with the WebSocket API. You need to have that WebSocket API implemented as part of the browser. That is the only dependency, because the endpoint is hosted by the Glassfish runtime. You would need a WebSocket container, at least some sort of WebSocket container. So for now, I'm using Glassfish, which actually has the Tyros implementation integrated in there. So you need some sort of WebSocket container that will understand that WS protocol, be able to do connection negotiation, handshake, all that stuff.
Understand these annotations.
Right. Yeah. How does WebSocket scale effectively? I think the way we see it is HTTP is about horizontal scaling. This is more about vertical scaling, WebSocket. In terms of that, HTTP, you can easily add more processors and say, you know what, I'm going to run scaling that way. In WebSocket, you are definitely limited by the number of ports that are available on your machine. So for example, if you're opening a WebSocket connection on one WebSocket endpoint, you can open as many as you want, but that is again restricted by the number of ports that are available. So the scalability concerns I have not studied myself well, and I've not started playing around with it yet. So I don't have a conclusive answer, but that's how I understand. Yeah, the question is there any analysis that is being done in terms of either using HTTP and WebSocket in terms of how much chattiness is actually being reduced? So if you take a look at the I think one of the non-normative WebSocket documents, that means a sample WebSocket document itself says how a simple hello world takes over 2 kilobytes of data that is to be exchanged between client and server. With WebSocket, that can be done in about I think about 150 bytes or so. So there is definitely a huge performance improvement, and that's actually a quote coming from Ian Hickson, who actually authored the very first version of the WebSocket specification itself. The question was, now that there's Java API for WebSocket, are there plans for Java API for WebRTC, real-time communication? Take a lead, run a show, run a JSR. By all means, we take contributions.